In the previous video, I tried to drive home the idea that the trig ratios are completely dependent upon the angle and completely independent on the size of the triangle. And the size of the triangle doesn't matter if we scale it up or scale it down. So since we can scale it down, what we can always do is we can always think of these triangles in the simplest possible way. And the simplest possible way is if we were to make the radius equal to 1. So here comes the idea of the unit circle to help simplify things. Now what we do is we conceive of a point, and I got point D on this right now, but point D is a point that's on the edge of the circle. So as we move the point from the initial side to the terminal side of our angle, we can have this letter D land on different XY ordered pairs around the coordinate plane. So everywhere that point D stops, it's going to be associated with an XY ordered pair. So the first thing I want to do is I want to demonstrate how we're going to expand your definitions of trig functions. Typically, when we look at an angle, if I call this angle theta, then the sine of theta we have memorized as the opposite side over the hypotenuse. But if we apply this to a unit circle, most of the time what we'll say is, well, the opposite side is really nothing more than the length of the opposite side, which is the coordinate of y, and the hypotenuse is always going to be the length of your radius. So the sine of theta is sometimes referred to as the y value over r, or the length of the side opposite, which is going to be designated by the coordinate of y, over the length of the radius r. So in a similar fashion than the cosine of theta, since we have that as adjacent over hypotenuse by definition, then if we apply the unit circle idea, then this side that is adjacent down here in blue, that is always going to be associated with the x value of your coordinate over the hypotenuse, which is always going to be associated with the radius. And finally, if we're after the tangent of theta then can be thought of as the opposite over adjacent by our former definition. And now we could redefine it. The opposite side is the value of the y coordinate of the ordered pair, and the adjacent is the x coordinate of the ordered pair. So what we end up doing is redefining and giving some new meaning to our trig functions. So I have listed those on this document. I'm going to remove this visor, and what you're going to see is our trig ratios expanded. So here's our definitions in an expanded view, all 6 of them. So we no longer have to think of sine of theta as the opposite over hypotenuse. We can think of them as y over r. Instead of the secant of theta being the hypotenuse over opposite, it's r over y. And it gives us a shorter method and a better method of describing angles as we go further around this unit circle. So as I said earlier, we've only dealt with angles in this first quadrant right here, quadrant 1. Now we're going to explore what happens when we get into angles that are in different quadrants, such as angles in quadrant 2, 3, and 4. So we'll be looking at obtuse angles and so on. So I just wanted to explain these definitions expanded a little bit further detail than what they did in the book. So